So we can kick it off, I guess. We're right here at 11:30.
Right.
Others may join, throughout the session, which is great. And this is sort of Lunch and Learn number 2, part of the, as we, mentioned early on, the sort of kickoff and just getting started with this. So we're building up some more formalism around it. And actually, that's what I wanted to talk about here. Last time, we sort of encouraged folks if they wanted to stay in the loop to simply create a login with us, sign up. And you can do that hovering over login and then over sign up now or clicking any of the check it out links. That's actually going to create an account for you at Sixclear.com, and you'll be able to check out our training stuff as well. But more sort of lightweight, if you just want to get updates, the newsletter, and then specifically reminders about these kinds of sessions, you can scroll all the way down to the footer, and the subscribe link here will actually get you to a place where you can even choose to get just the LabVIEW Lunch and Learn webcast reminders in addition to the newsletter. And that would give you something like a same-day reminder that, hey, the session's coming up in an hour. Nothing more than that, nothing super heavyweight. So anyway, that said, this is number 2. Last week we did one as well, and we will continue to do these at least monthly or so for the foreseeable future. And hopefully we'll be able to share more with the community, all of us together sharing. So if you're interested in presenting as well, check out the update you got from us last time. There's a link in there to share, to contact us and to share ideas that you might want to get on the schedule for these Lunch and Learns. So awesome. All right. That said, Casey Lamers from Phoenix Nuclear Labs, that is. Thanks so much for joining and for presenting today on the unit testing with the VI tester, the JKI VI tester. I will now pass you presenter rights, and you can take it away.
All right. Thanks a lot, Jazz. I have accepted presenter rights. All right. So as mentioned, unit testing with VI tester. I think the Lunch and Learn might have said testing AF. I employ a lot of actor framework in my coding, so I'll get into that too. I'll start with a little background on me, our project, and then a little background on the VI tester tool, and then I will show some live demos of how it works. So let's go to the next slide here.
And Casey, one more thing. This is rookie error here. Let me at least mention to the group here, if you have questions, everyone's line should be muted other than Casey and mine, and that's just to reject background noise that might happen otherwise. That said, please use the chat. You should see a little chat icon in the Join Me environment or in your browser, and use the chat to ask questions. I will monitor that actively and will reflect those questions to the group so that Casey can answer them for everyone. So use the chat to ask questions as we go. All right, sorry, take it away.
No, that's great, because I do like to have conversation as we go. It can help me steer this and answer questions that come up right in the stream rather than just wondering about it and leaving it hanging out there. So a little bit about me and the company I work for. I work for Phoenix Nuclear Labs. I'm pretty sure there's some people from Texas that don't pronounce that right. Former president, for one. So I'm our head software engineer, and the system we use, we write our code with LabVIEW. It's deployed to compact Rio controllers where we write code for the FPGA and the RT layers. While I've been here, I've helped implement Agile practices and continuous integration. And our product is a nuclear fusion particle accelerator. So we make lots of neutrons for various applications. This is what one of our solid models for a system cutaway here that this system is deployed to the UK for a company that does neutron detector fabrication, and they use our system as a verification tool for their quality control on their manufacturing process. This is a pressure vessel. It stands about, I don't know, 8 or 9 feet tall. We hook up a 300 kilovolt power supply and accelerate ions down into a target. Near the target, there's some test cavities, and at the target is where we make all of the neutrons. So there's about a dozen power supplies, all the way from the big guy that's 300 kilovolts down to smaller tens of kilovolts to single-digit kilovolts for all DC for manipulating our ion beam to get it down to the target. And then we have some control algorithms. The software architecture, like I said, it's an actor framework. It uses the model view controller type of system architecture, and it's a finite state machine where there's a system level, subsystem level, and component level pieces, and a hierarchy that gets set up and all the messaging between them, etc. So here's a little video. This is an image of the actual system, and here's a video of the beam running. I don't know if my chat window isn't in the way. So this is actually a system that's deployed to the Army for doing neutron radiography, so analogous to X-ray imaging, but they use the neutrons to look for defects in explosives inside ammunitions. This is a video from, I want to say, almost 4 years ago of that system that's at the arsenal when it was still back at our facility. Let's go to the next. Well, let me first, I'm going to give you a little bit of reasoning why we want to do this testing. So part of the Agile process is this idea that you work on code that's ready to be worked on. And one of the things about it being ready is it's you can define what you're trying to do. You can figure out an endpoint so that you know that you were successful in writing your code. So this testability is a key feature in my mind to what something being ready is. Now, definition of done, this is another part of Agile, is that when you do your work, you want to have this metric that you're done, and I've listed a few things here. It's not just writing some code. There has to be the supporting documentation, testing, building, functional testing, reviewed and approved by both our internal team and the owner. Ideally, this would be someone that's a stakeholder at the customer. And then I guess you could probably say potentially deployed and potentially shippable. You may not deploy code that's done until more features are done, that sort of thing. And if you just search definition of done, you'll get a whole bunch of links related to Scrum and the definition of done. So a key piece to that, though, is this idea that you've tested your code. So what do we want to test? And there's a few bullet points here. The big thing that I test is the public API, so application program interface. My application, being an actor framework application, my main public interface are to contained classes that do things, that do work inside of the actors, and the messaging between actors. So those are things that I am keenly interested in testing. We're going to test code that covers requirements. We want to make sure that we've met our design goal, and that we cover the things that the customer wants, that the system needs to do, and that meets engineering needs. Some of the things that you're going to test are for internal state or posted state, and then behavior, which is more of the, now that you've achieved some state, what do you do? And so that behavior in Active Framework a lot of times involves sending a message. So a message comes in, we're going to check the state of the internal state, and then we're expecting the thing to do something. And finally here I put anything you enter values into and press the run button to see the output. So this is one of the things that I want to emphasize. Writing tests does not mean that you have to spend a whole bunch more time developing. And that's one of the pushbacks you'll hear when people are saying they don't have time to test because it would add all this overhead. Odds are when you're developing, you're doing testing as you go. The problem with those tests are they're not documented, repeatable. They're not something you can give to a client and say, here is the proof that I did what I said I was going to do, that the code works the way we want it to work. When you press the run button over and over, when you're fine-tuning, you don't generate that trail, that traceability, that you've actually done what you said you were going to do. So it's worth the little bit of time to actually formalize it into a test, and then you can reproduce it. You can rerun the test when your code base changes and make sure that it still passes the test. And if it, you can, so it's a good thing to have for a lot of reasons. So I guess I kind of just said this traceability, it falls under the why we're going to do this. You know, you don't, there's a lot of people that are in unregulated environments, so they don't need the traceability. But I like the sense of the proving to myself that it works. I also like when I make changes somewhere, I can catch errors early. So like if I make a change to my code base and I didn't think it through what that change means, and now I check to see if the behavior of my system is as expected and it isn't, then I can catch it right away and I can fix it sooner. And the sooner you're able to fix your code, odds are you're closer to the code that you were working on. Your head is in that space where you're not having to come back and figure out what you were thinking months later. So catching those issues early is useful. And so a couple other things here. Define upfront what you're working on. There's test-driven development. We don't actually employ test-driven, which test-driven development actually states that you write the tests first, and they should all fail. And then as you write the code, you will get your tests to pass. And ultimately, passing of all the tests means that you're done with your code. So let's go to the next slide here. So I think actually, yeah. Well, I'll show this, and then we'll do a little demo, and then I want to show you some UML diagramming that informs tests to run, and then some running of tests to cover what we decided we were going to need to cover. So JKI, many of you should know JKI. Jim Kring founded JKI. They're out in the Bay Area, and this is a free tool. I think Omar Musa did a lot of work on this tool. I'm not sure if he did all the work on this tool, but he did a lot. It's based on xUnit software testing, which is, it's changed, there's a JUnit for testing Java. I guess this isn't like a gUnit, but VI Tester is based on a testing standard. It uses a format of test cases and test suites. A case is an individual set of cases or a set of tests, and then a suite can be a set of cases. They implement a few sort of standard steps. There's a setup, there's a test, and then there's a teardown. It uses what's called a fresh fixture, which means that if you have a whole bunch of tests that use the same setup, they don't retain their values at the end of each test. So they each test within a test case will have a fresh setup. So the data is initialized each time. So there's no retaining previous values that could cascade. There's both a GUI, graphical user interface, which is what you see here, as well as a command line tool. I know that, so I got the command line tool by basically by hiring JKI to set up some of my continuous integration tool chain. And this is one of the tools that you can call from a build script. So that's part of my continuous integration process, is basically running the tests as part of the build. And it's actually a gate for the building the executables. The tests must pass before the executables are built. So I think what I got next here is a demo of the VI tester, and I think it probably makes the most sense to just sort of start from the beginning here. So I have a project here, and this is just it's maybe something you would some simple examples here. So I have I want to create an average of some number of input values, and this isn't totally contrived, because I actually use this for figuring out a statistically significant number of samples to take the average for my closed loop control system on the neutron detector calibration system that's deployed in the UK. So I have a desire to know what the average number is. Now what I actually do is I have an array of timestamps where I say I need to get so many pieces of data out and take the average. So there might be there's a varying amount of data from this array that I need to take and create an average and drive a PID closed loop control algorithm. So this is pretty simple example here where I'm just wanting to compute the average of some numbers, and you know, this isn't overly complicated, so, but what I just did is you know, press the run button and try a few different combinations of data entry, but I haven't actually got anything that I can reproduce. So that's where creating a test comes in mind. So the let me take a step back and show you how to create some tests. Actually, so VI Tester is gotten to by going to Tools. There's a VIPM for getting VI Tester. VI Package Manager, also written by JKI. Michael Eviliotis did a lot of work on that. So you get that package, you install VI Tester, it's free, and then you have this tool. And so it actually loaded the tools that are in this project, and now I could run tests. Now, if I want to make a new test, you go to VI Tester, and instead of test VIs, I can specify a new test case or a new test suite. So let's just make a new test case, and it's going to ask me what I want to call it and where I want to save it. So here I'm in this folder called Support VIs, and you can actually see the My Test Case and My Test Case 2 folders here that go with these, and a folder for each of these other add integration segment, double FIFO, enough valid data, signal average. So I'm going to create My Test Case 3. When you create it, when you create this name, you don't need to create a folder by that name. It will create it for you and put it in that folder. So here it's running some scripting tools, and presto magico, My Test Case 3 exists, and you can see that it lives right next to these other folders. So let's just take a little tour of the class. So by default, it contains a Boolean set labeled none, set to false. And this is something that, this is all object-oriented. So when you get to actually, well, you can use encapsulation, etc. So here in setup, you can see that this is not an RT target. It takes it sets a value to that. This is just sort of to tell you what you can do. So a lot of times the first step I take when I create a new test case is I replace the private data with things that I'm going to need to do some setup on, and then presumably I'll access that data in the test, and then I might need to do some teardown as well. these first examples with just some number manipulation don't actually take advantage of the data being stored in the class, but just be aware that that's a key tool here is the fact that there's private data. Teardown, just, it doesn't do anything here, but you could, if you had a file reference that you opened in setup, you can close it in teardown. If you have a event that you created in setup, you can destroy it in teardown. So, and then there's a test example here, and this is what we're going to do. We're going to right click on this, and we're going to say new from template, and this is going to create a test for us. It creates a test called test example 1, and we can save it, and test example 1 is fine. And here, this is where you might take data out of the private data and do something to it. You might just run one of your VIs, and then there's all sorts of different tests. This is a test for equality. Let's see. So there's different tests here, and pass if equal, pass if error, fail if equal. I basically have just been using the pass if equal, and I come up with an algorithm where I expect a certain state, and I test for that, or I expect a certain value and I test for that. So let's look at some of the tests that I've done, and maybe these are supposed to be easier. Here's a test where I'm averaging 4 values, and this is that VI I showed you before, where I have 4 numbers going in, and I'm expecting an average. So 2, 4, 6, 8, I'm expecting an average of 5. You can do as many examples like this as you want, and you can basically copy. So you just save as, open additional copy, add it to your test case, and or something like that. And now, I can say instead of 2, 4, 6, 8, I could do, 4, 8, 12, 16, and the average should be 10. And so it's not too hard to put in a bunch of test cases. This is analogous to what you were doing on the front panel of this VI, right? So if you had this VI open and you were entering different values in to test the outcome, this is the same thing, except now you've got traceability. Now you've said, I tested it these ways, it produced the expected result each time, and therefore I'm confident that my code, that piece of code, that unit of code is working. So you have to save the class in order for it actually to get added. So when you go to test VIs, you'll see in the signal average test here. Load it. there's the B one that we just wrote. So if you highlight a individual test, you can press the run with the 1, and it'll run just that one test. So here's the one test where the 4 values add up or average out to 5. Here's the one test where they average out to 10. If you highlight the class, where all of the test case class, where all your tests live, it'll run all of, actually I just pressed the wrong one. Oh, and dog does not equal cat. That's the, I was going to say that if you highlight your class and press the run 1, it'll run everything in that one class. And here, when you get a failing test, you can say, well, why did that fail? Well, this is the example, of course, and wouldn't you know, they have cat equal, or checking for cat and dog equality, and it doesn't equal. So this is maybe an example of test-driven design where the test fails to begin with until you've written the right code. Actually, probably what you would do is you would keep that dog and you would change your VI under test to produce the right output, right? So, and then you run your test. Just a couple tips here. The more tests you have and the more classes that the tests use, so this is an actor framework tip, the more time it takes to load and run the tests. So sort of a best practice, I would say, is probably limit the number of tests that you have in a given project to a couple hundred or less. Break it up if you're going to do a lot more than that, just for IDE, load times, and performance. If you have more than that, it will do it. It just takes longer. I had a time where I had 600 and something tests in one test suite, and it would take a long time to load. And by a long time, I mean on the build server, loading and running all the tests would take like an hour. And if you divided it into 2 test suites that had about 300 each, they would take about 15 minutes each. So you do the math there. It's the same number of tests, but the layout of the test suites and how many tests they're running can affect your performance. So are there any questions so far about how to create a test and run a test? Because I'm going to move on to some actor framework examples so that we can see how we test the messaging interface. I wanted to start with any. Yeah, I'm not seeing any either.
Yep, no questions so far. So if those are out there on the line, yeah, if you have questions, throw them in the chat, and we'll reflect those here on the line. But otherwise, yeah, carry on. This is awesome.
Okay, so with regard to breaking up your tests, I'll just show you a little bit of my disk hierarchy here. So I've got a Git repository, and inside of here, I keep projects, source, and tests in 3 separate areas. And you can do this in a different way if you want, but I do something with my testing. Well, one, I want to keep my test code separate from my source code. Inside of my test here, I have a folder for specific projects and a folder for all projects. And so when I am working on a radiography device, I'll have a test suite for that system. When I'm working on the ultra-electronics neutron calibration thing, I'll have a test suite for that. Here you'll even see that I have individual test suites for each of my subsystems on this project. And this is my this allows me to do a simple disk search from the directory that the test lives in and underneath, like the hierarchy, the disk hierarchy recursively beneath it for tests, to run in one test suite. So we haven't talked about test suites yet, but I'm going to show you that next. So, so here I've got system manager testing, and I'm going to open this. This has, I think, 270 some tests in it. I just ran it to make sure everything worked. One thing I had to do here that's worth noting is that recently I've been doing a bunch of refactoring, and it's breaking a whole bunch of tests. And so that means that I can readily identify what code is not working how it should because of the changes. I came back to this, I actually, in my repository, I went back to the release that's released at the UK site so that I would have all working tests. And actually, now that I open this, I see this is not going to have the test suite in it, but I'll still demo that shortly. So tools, VI tester, test VIs, and it's going to scan for all of the tests, all the test suites and test cases inside of this project. Here we have the 277 that I was mentioning. Now at this point, I want to show you this this documentation here, because this was the driving factor behind writing these tests. So there's design work, well, there's requirements gathering, then there's design work, and then there's coding and testing. And, you know, it forms a iterative loop. So I did some, there's a full state diagram here, and actually this is a newer version than what I'm testing right now, these are all different states of the system. And just a brief intro here, you power on the system, it starts uninitialized, it immediately enters into auto mode and initializing until all of the subsystems are finished initializing, then it's off. Then it can go through some different states, bringing it all the way up to beam on. At any point with the right credentials, you can ask to go to manual mode, or some non-recoverable faults can occur, like the gate can open and the e-stop, the access control system can act, and then the software can catch up to the hardware's stopping. So this is just a state diagram, and then for each state, I've generated a decision tree. You know, I'm uninitialized, I immediately go to initializing. I'm initializing. Are all of the watchdogs reset and all of the subsystems initialized? If yes, then go to off. If no, then stay in initializing. if I'm off, so on and so forth. There's these decision trees. Over here, there's also some messages that my system manager needs to send depending on the state that it calculates. So here's an entry action in the off state. If neither the ion source nor the accelerator column are on, then I tell my system controller can tell them that they're both allowed to be either on or off. But here, if I have my source is on, I tell my accelerator column it can't turn on. So these are behaviors. So the result of the decision tree is a state, and then there's also a behavior, an action that the system takes when entering a state and or when exiting a state. So you'll see different decision trees. Here we're in a state where I don't want the ion lens or target to turn off, so they're told that they must stay on. And so you walk through and you get different results, so different data coming in with a question basically, and then resulting states and different behaviors. So that's what now that I've got this documentation and I've written some code, now I'm going to test, does my code do what I wanted it to do? And so here, system state transition tests, energizing column, there's a bunch of commands that I'll handle. I'll ask it to go to manual mode, and you saw that was one where it would go over to a manual mode. There's a error, there's a safe. Here, if any of the watchdogs go bad, then I expect it to go to the error state. So let's dig in a little bit to what this test case looks like. So it's an actor framework project, so not surprisingly, I have a bunch of, and we're testing for internal state as well as messaging behavior. So here I have 4 enqueuers for the 4 subsystems that I'm going to send messages to. I also have dequeuers so that I can see when I sent a message to this thing that basically I'm intercepting the message, and then I'll do something with it. And here the system manager is my main actor, my system actor that I'm not really launching but pseudo launching for testing. So let's follow the template now. So there's a setup step, and then there's a test that gets run, and then there's a teardown step. So in setup, I need to get all of these queues so that I can do something with them. And I'm also going to manipulate the internal state of my system actor so that then in my test I'll send it a message and check for internal state change and for messaging. So this is a little bit busy, but let's just look at it quickly. So I've got my system manager, and I've said this is the energizing column test case. So I set up my contained state class that's internal to the system manager to be in the energizing column state with this nice little enum that's internal to it. Then I set up initial states for my 4 contained subsystems. This guy is an aggregator of subsystem states, so this is what I know sort of going in. and it allows me to get my main actor into the right internal state. This is a obtain queue method, and the actor framework obtains queue pairs, an enqueuer and a dequeuer. So if you want to send messages to something, it's enqueuer, and then it receives messages on its dequeuer. I build up a set of 5 of these, and then I put them into the different pieces. So we got a ion source queue, an Excel column queue, an ion lens queue, and a target queue. And then I also keep their dequeuers. And then I keep this queue array here so that I can destroy it in the teardown. So these you remember from here, okay? So here's my my main actor gets a bunch of internal state stuff set. I sudo launch it. I give it its own queuer. This is a actor framework testing VI. Let's see what it's called. Can't remember. It's init actor queues, and then all caps for testing only. So this basically, it's like launch actor, except it doesn't actually launch the actor. And it does give a queue out and a dequeuer out. I need unique queues for all of these guys, so that's what this creational code is doing. It's creating unique queues. And then, so now I've got a unique queue for each, and now let's run a test. So, as you might expect, this is an actor framework message with some attributes. This is a counter that is one of the watchdogs. So this is the update the counter state message, and I have this has the count and whether, which is a integer, and then a Boolean as to whether or not the counter needs to be reset. And this is do.vi. So actor framework will call the do method of a message and execute it. And then I say, okay, let's dig in and get the state class out of my system manager, and let's get the so I'm checking for its internal state here. So I'm gonna, it has a contained state class which has contained data. It's got the enums for all the subsystems, and it's got a bunch of other information in there needed for calculating state. And I'm going to say that this watchdog needing resetting is going to cause the internal state to change to this transition to error state. And so I can't see here. This is the system energizing column. I think these are organized by the order they are in the project. So here, energizing column, transition to error on command is this guy right here. So it's like this fourth one down here, the main UI watchdog. This is another way to get at that same VI. Note that if you edit this, you need to save it and reload it. The ones that are here are basically in their own space. They're loaded and stored sort of separately. Now let's just run this one CI. Takes a little bit of time to go the first one because it's loading a bunch of stuff into memory. When you run these, you can probe on them. So if you wanted to probe the wires, this is a performance issue that's been solved in LabVIEW 2015, by the way, this sort of delay here. So if you probe, you can actually, when you run the test, you can see, you gotta get the test window open. You can see values actually get populated, and you can see more than what you were just testing for, but you can see here that my counter value with the 6 and needing resetting got put into this big cluster. And down here you can also see the enums that were put in for the setup. Let's say now you actually want to look in this do. So the do.vi is like your kind of your gateway into your actors. It's your messaging interface. Here's the update counter state message, do.vi. And we can say, okay, the counter state comes in to this system manager, and the system manager says, you know, if I'm the default guy, it's the main chassis, UI watchdog. If I'm named secondary chassis, it's the secondary chassis. The data comes in, and then here, calculate system state gets executed, and that is there's a state class which is contained, so our state check depends on that decision tree, and the decision tree is broken down. Instead of it being sort of universal, it's broken down state by state. Then I got an exit action, an entry action. So here, this is a template method. So we were in the energizing column. Here, this is analogous to the decision tree. I'm checking for an error or if the watchdogs need resetting. If that's true, I go to the error state. So we can just refer back to this diagram, which would have been this. So actually, I've refined this since I wrote the test code. There used to be a transition to error state, and now we're deciding there's going to be a system fault state and a system fault handler that's going to sort of run next to this. So that means I'm on the hook for a whole bunch of new tests. So that's why I had to roll back to the deployed code base so that my tests would pass. After that, I'm checking for a fault in the high voltage power supply. If there is, I'll go to this state. If there isn't, then I'm checking that the lens and the target are both good. And then I'll check for if the column is energized, and I'll go to one of these various states. So you can see that enum sort of present in all these different cases. And then I continue through the template, and I may send some messages too. So let's look at what a test where, aside from just evaluating internal state, we're going to look at a message to another subsystem. So let's see here. So here's one where it goes from energizing column to column energized, and it tells the target that the target has to stay on. And that's, so column energized here, entry action, tell the target and the ion lens that they have to stay on. This is because we're sort of coming up this ladder here, and once the accelerator column is on, if we want to turn on the source, these guys have to be on. So we tell them they have to be on. So let's just look at one of those. So here's the allow on message. So the setup is the same. This time we're getting a message. Let me put that back on so you can see it. So this is a subsystem state message that the accelerator column is now in the on state. And here's a do.vi. Now we're not actually measuring the internal state of the manager anymore. I'm looking at the target message dequeuer and checking to see if it gets a particular message. And what I'm wanting to see is I'm wanting to see this subsystem, allow subsystem on, off, or both message to contain a payload that is the allow on message. So the setup, you recall, or I'll show you quick, for this, got all of these dequeuers ready. So there's I'm going to send a message in, and it also got the enqueuers for the different subsystems. So the message in is that the Excel column is on, and then the system itself is going to send a message to the target saying, stay on. And so this is how you can test for behavior of an actor, specifically that it's executing messaging to other actors that it knows about. So we can go ahead and run, more of these. So here's the allow on, off, or both. Here's the one to the target. Run the one, and I think I clicked to the run, but there we go. So there, that's exactly what it does. Now you can come back and run them all. We're getting in. Jazz, how long are we going on this?
It's actually open. We knew that the presentations would vary in time. We can go as long as you have time for, and folks can obviously, pop in and out as necessary for work purposes. But yeah, feel free to continue. Go into as much detail as you want. This will be up on YouTube afterwards, so people can find the rest of that detail there. I'd say, yeah, go ungated. All right.
Well, I think one thing that I still need to cover is the idea of test suites. So these projects so far that I've shown you have all of these test cases in them. But what I described earlier is this sort of ability to scan your disk for tests and run tests in a certain location as members of a test suite. And that basically can generate a list like this automatically, independent of where you actually develop the test. So I like to, develop the tests kind of locally. You'll notice the target on all of these is my computer, even though all of these were written and they're all deployed on a compact Rio. So you have to have a different project for your testing of code that runs on your compact Rio. But then organizing it and running it, I'll just show you an example here now. So open existing, and I'm going to open a test suite. and I don't know if I'm going to run this test suite, but I want to show you some of the concepts of a test suite. So the test suite, you'll notice the setup and teardown, and then there's this VI called new, and this is one of those. It's a reserved name, and here we're figuring out what tests to run. And Justin Gores is to blame for this, but basically what we're doing is we're looking at our current location on disk, and we're searching the disk to find test case classes recursively from that location, and then we're casting them all to test cases and building up an array of test cases. So when you do something like this, you can basically park a VI like this in a location that you want to have a bunch of tests underneath it. So here, the all project test suite is going to test my system level code, which runs all these system manager testing. I just had this system manager testing test suite open, but it also runs my component testing. So some alarm stuff, some state stuff for a power supply. It runs these averaging and checking things. It runs some reading of a config file. So my all projects stuff is sort of the reusable pieces that I expect to want to test regardless of the specific implementation. But then I have these specific projects where I'm going to just run unique subsystem tests, because the system level code on my project is the same, and the subsystems launch the same components, but the subsystem's internal logic is slightly different because they might have a different mix. So I put the suite where relative to the tests that I want to run underneath it. And then you can do something here where you build up a list. An alternative to this building up a list from the current location is you could specify a hard path. I recommend the relative path that works for the build server purpose, because each build spec I have uses a different disk space. Like it'll pull a copy to a new path. So the relative path is pretty useful. But you might do relative to this path, find, class A, B, C, D, and have it be fixed. And then you're not just sort of recursively searching, but you're specifying these are the tests that belong to this suite. And so when you do that, you'll notice right now there's no, well, I can show you the dependencies too. There's no tests here. No test cases, just the test suite. And so here you can go Tools, VI Tester, Test VIs, and it will open up this. And now the scanning for tests, I'm hoping this isn't excruciatingly long, but it is running that new .vi as I speak, and it's searching through, it's running whatever that algorithm in new was. So in this case, it's this recursive search of disk. And the other reasons you would want to do a test suite is setup and tear down can give you additional functionality that you can implement for every test in the suite. And you can use dynamic dispatch methods. So you could have a something in your test suite where you want to do some sort of preparation, some sort of step ahead of time, and you want it to, and you maybe want to vary it by test case, and you can create a new VI from dynamic dispatch template, or a new dynamic dispatch VI, and then you can override it in each case and or in each. So let's see here. So in setup, here I'm not doing anything, but you could configure the test suite in some way. In new here, I could, when I get all these test cases, I could do something here that's dynamic dispatch for my test cases. Now the issue here is that if you're going to do something specific that uses a dynamic dispatch method of your design, you're going to need to cast to your type of test in order to gain that child implementation's additional methods for action here. But that is, it's allowable and doable at your discretion. So the tester opened, and you'll see that all of those system tests are now in here, and all of the component tests and alarm tests, etc., are all in here. I didn't, and the array tests that test for values _B is right here, and none of these were initially in the project. Now they're all in memory. All of the classes that go with them, etc., are in memory. All of these weird named ones are JKI VIs, and you can ask them about what the reasoning behind that is. But so now we've loaded up, based on path, all of these tests. So I think I'd like to maybe go back to the PowerPoint and wrap it up. There's a few more. So running the test suites in my build, it's one of the steps that I do. So I use Jenkins with an Ant script to define my build process, and the jobs that I have enabled will run the tests that I define. And so for the Army radiography system, I'm not going to run the tests for the ultra-electronics system. I'm going to run the radiography tests, and I'm going to run the tests that belong to all projects. So the build script can define that, and then I can invoke VI tester from within Jenkins, and it runs this command line version of it. This also will generate in the sort of the console output for the build. It'll output all of the results from the tests. And passing the test is a gate to building I guess I just said a bunch of this and showed you a bunch of this, but the project-specific suite and the sort of the non-specific all projects suite are pretty common. I might be further breaking this, but I haven't. This is at your discretion. Basically, as I said earlier, the performance when you get too many tests with too many classes, with too many methods, starts to suffer. So breaking it up is not a bad idea. This is a book that I've read a good chunk of. It's kind of, I don't know, it's not a real page turner, but it's one of the most highly recommended books on the subject for how to write tests. So you can, just like code, you can write good code and bad code. Well, with tests, you can write good tests and bad tests. And you don't want to have a maintenance issue. But I would argue that if you write your tests well, if you change your code and there's a bunch of tests that fail, it's not a maintenance issue, it's a fix the code issue. But I think there's a learning curve to writing good tests. Hopefully some of the pointers I've made about testing the public API, messaging interface, and that sort of stuff, internal state and behavior of the module will be a good guide for you. Again, who I am and how you can contact me. I am pretty open to helping people, so wherever I can, if this is something you're interested in and you need to know more about, let me know. I presented this same topic to the NASA user group meeting at Stennis Space Center. And so if you want me, if you think this is something that's appropriate for your group, like if you're remoting in and you want this presented to your user group, or I have a continuous integration talk as well, get a hold of me. I'm one of the experts on active framework and testing, so use me as a resource. That's that's the end of the presentation, and I think I'm at a good point to stop here.
Excellent. Casey, this is awesome, and thanks for that generous offer to everybody in the community to reach out to you for presentations. Regarding continuous integration, that would be an awesome thing to have you back for some time if you'd like, and as these Lunch and Learns grow. This is number 2, and man, we've had 2 excellent ones. Thank you very much. This was comprehensive, informative, totally awesome, man, totally awesome. Thank you again. And that said, for those out there who are interested in presentations like this, basically topics in and around LabVIEW, and hopefully we're able to share as a community more of these ideas, become more effective programmers all around. You can subscribe to get the updates and even reminders on the day of the Lunch and Learns at Sixclear.com/subscribe. You can also follow us on Twitter, and we usually tweet before and even during some reminders for these things, and also try to promote and highlight the presenter, in this case Casey and Phoenix Nuclear Labs and those kind of things. So that's kind of cool as well to stay in the loop on where these guys are working, what they're working on, things of that nature. Very fun stuff. So yes, Twitter.com/Sixclear will get you there as well. But Casey, thank you again. This is awesome, and I look forward to catching up with you again sometime in our hometown of Madison, Wisconsin, sooner than later.
All right, very good.
Excellent. Thank you, sir, and we'll see everyone next time.
All right, bye now.
Mm-hmm.